All right, so remember this is on page 16 of your INB notebook. Okay, that notebook, we're going to go ahead and write this on there. These two oxygen isotopes, this is an example. Just a quick reminder that the notebook's going to be due next week. I'm probably going to start grading it around Tuesday. Okay? Remember, it's a test grade. Yes. Okay? Now, if you notice, these are oxygen atoms. You have the same number of electrons, and you have the same number of protons. Remember that proton gives your atom its identity. Okay, let's turn off those phones. Okay, now, the neutrons here are 8, which is why you have a mass of 16. But your neutrons here on this atom are 10, and that's why your mass is 18 instead of 16. Now, don't forget, every time you have a nuclear symbol, the mass goes on top and the atomic number goes on the bottom. So for oxygen's isotope, you'd have 18 on top, but my atomic number for oxygen is still what? 8. So that goes down here.
Why are those different for both the same?
They're both oxygen, but what changed is the mass. Oh, why is this stylus not working? Okay, so remember the mass is what changed right here. Okay, and the reason the mass changed, Mark Anthony, is because your neutrons changed. Because remember, your protons and your neutrons is what gives your atom its mass. Okay? Do we need a little more time? Yesterday, we looked at the ion of an atom, and that changed the electrons, right? But today, we're going to look at how the neutrons changes your mass. So that's what an isotope is. They're the same element, like you can have 3 or 4 different carbons, but all of them are going to have the same proton number. Carbon is still going to have the atomic number of 6, but you can have a carbon 12, a carbon 14, a carbon 15. Those are all isotopes. That means the neutron changes, therefore the mass changes. Okay, now the proton always stays the same, because if you change the proton, you change what? The whole atom, right. It's a completely different element. Okay, because remember that proton identifies your atom. Now, this is what you have on your page 14. Look how you can identify the atom that you have. I have 1, 2, 3, 4, 5, and 6 different protons. That's how I know that this is carbon. Okay? Now here, I also have 1, 2, 3, 4, 5, 6 different protons, but I have more neutrons. 1, 2, 3, 4, 5, 6, 7, 8, where over here I only have 6 neutrons, right? You see the difference there? And this in here, your protons plus your neutrons, is what is going to give you your mass. Okay, and that's what makes the difference there. All right, let's look at a different example. Your electrons, we're going to go over that next week with your electron configurations. They're going to stay the same as your protons. But the neutrons here, how many do you have on lithium over here? I have how many neutrons? 3. So that's why your mass is 6, right? But over here on this side, I have how many neutrons? 4. And that's why my mass changes on this lithium. Okay? Now, what I'm going to show you today is I'm going to show you how to calculate an isotope when they give you a percent. Now, little quick reminder, because it's going to be on your worksheet today. A nuclear symbol. And did we do this yesterday?
Did we write that down?
Yes, I would make sure to write that down. Any number that goes on top, so for example, if I have carbon, the 12 on top This is your mass number. The number on the bottom is your atomic number. Now, why is this important? Because on your paper, they could be giving you a nuclear symbol. Let's say instead of 12, I give you something else. Like, let's say I give you 14. Okay? Now, does this match what's on your periodic table right now? A carbon 14? No, it doesn't. Very good. Because on your periodic table, it says 12, right? So that means that on the worksheet that I gave you today, they want you to use the mass of 14 because it's an isotope of that element. And they want you to figure out the rest of what you have with that mass. Okay? So remember, this is a nuclear symbol. The top part is always your mass number. The bottom number is always your atomic number. Okay? A number placed around the element always means different things. Remember, yesterday we placed something over here, and that was your charge, right? Okay, so wherever you put a number is going to give you a different type of information for that element. Giving you right here on number 1. They're giving me 80% of iodine, and that's 127, right? Now, sometimes you have a dash. That does not mean it's a negative. It's giving you still the mass, okay? All right, what does the next one say? 17%, very good. Of still iodine. 126. And so they can write it both ways. They can write it this way, or they can write it this way. Okay? That number is still your mass. Okay, and my third one there, 3% of iodine, 128. Okay? Now, remember that you must show your work. Okay? Now, because it's a percent, you're going to move the decimal twice to make that a decimal. So you're going to have 0.80 times the mass, and your mass is 127. So 0.80 times 127, how much is that? Very good. So 101.6. All right. Now we're going to go to the second one, and here's 17. Remember, your decimal is always at the end, so you're going to move it 2 times. So 0.17 times 126. Now, what does that give you? 21.42. Very good. Okay, now let's go to the last one. Now, you're going to do this whether you have 2 elements or 8 elements. You're going to do the same thing to all of them. Now, here's the 3%. So here you go 1, 2. It doesn't matter that there's no number there. You're still going to put 0.03 times 128. So how much is that? 3.84. Okay, now you're going to add all of these up to get your AMU. So 101.6 plus your 21.42 plus that 3.84. What is that total? 126.86. Very good. Okay, that is your AMU. Now, what does AMU stand for? Let me go ahead and erase this up here, if I can. Okay. And AMU, that is always a question that's asked on the benchmark as well as the test. This is your average mass unit. And this is going to be one of the questions on your lab tomorrow as well. Okay, that's your average mass unit. That's what AMU means. So now you must show all of this work, okay, for every single problem, and you must put the unit on there as well, okay? Now, where do we have a question so far on what you're doing on each step? We don't have any questions? Are we sure? Mija, get off the phone. Get off the phone. We're on the lesson part. Are we sure we don't have any questions on how to get the percents into a decimal? Multiplying the mass? Nothing? Okay. Now, don't forget that it doesn't matter what you have. Let's say you have something like, sure, we're good? Okay, you're going to do that small little page first. A 0.5% of whatever element. Do you still have to move the decimal? Yes, 1, 2. So you would have 0.005 times whatever your mass would be. Okay? All right? Okay.